Recording. My name is Nick. Super excited to tell you about some work we have using protein language models and using them to score gene variant pathogenicity zero shot without data preprocessing or any fine tuning on MSAs. It's sort of amazing. We think this work fits into the growing literature indicating that protein language models capture statistical patterns in protein sequences and that are relevant for downstream tasks. So this is joint work with Allan Zhou and Dan O'Neill. We're all at Stanford University in computer science and electrical engineering departments. The task we're interested in this talk is predicting human gene protein variant pathogenicity. The challenge is we lack high quality labels, and the approach is going to be to turn to unsupervised methods and use likelihood as a proxy for pathogenicity. This is the evolutionary principle, saying that the proteins we observe in nature are subject to natural selection, so the less frequently occurring ones are more likely to be pathogenic. Prior work uses this principle, trains generative models, one for each protein family on multiple sequence alignments. Our work, we're going to use one pre-trained language model to predict protein pathogenicity, and we're going to do it zero shot with no fine-tuning, no MSAs, and we think this opens the possibility of really flexibly scoring any variant, and we're going to perform comparably or better than this Eve paper, which I'll say a little bit more about later on. A super nice paper that sort of fits a bunch of generative models using these MSAs. It's prior state of the art. We'll use protein language models though, and these are trained via self-supervised learning on large open data sets of protein sequences. A typical training objective is for the language model to predict the missing amino acids in a randomly masked sequence. This makes them ideal for predicting variant likelihood as a proxy for evolutionary fitness. To score a missense variant, we'll mask the sequence at the mutated location and output the protein language model's conditional probability distribution at that location. To define a pathogenicity score, we'll evaluate the log odds ratio between the variant and wild type at the mutated position. So here this set M is the set of mutated positions, mutant versus wild type WT, and we're taking the sum of the log odds ratio of these conditional probabilities. And so intuitively, S is higher when the mutations make the variant sequence less likely than the wild type, making it more likely to be pathogenic. So we can look at some results. Here I have the ROC curves for three methods. So VELM is what we're calling this method, variant effect via language models. And we can use pre-trained protein language models with different architectures. Here's T5 and BERT, just two of them. And T5 performs the best of the ones we tried. And you're seeing that the aggregate AUC, so we have some high quality clinical labels, and the details are in the paper. These are from ClinVar, and they're the same criteria is being used here as in Eve for selecting which labels are high quality. And when we compare across all proteins, we see VELM gets a AUC area under the curve, that is, of 0.91, and Eve is 0.88. So VELM is performing better, and so we can look at those scores for T5, the histogram, and see that you're getting good separation, or as I said, the scores are higher for things that are pathogenic, here being shown in orange. We also have results in the paper on per gene performance that you can aggregate by taking weighted averages, and there we perform comparably to Eve when you restrict to proteins that have a decent number of labels, like 5 or greater labels, and that makes that statistic of the AUC, the mean AUC over genes, less noisy. So this is showing these results, the one I have here on the slide and the one I just referenced, are showing that these language models are able to predict pathogenicity zero shot. We think this is a super cool result. We're really excited about it. We'd love to talk to you more at the poster session or via email, whatever's easiest to get in touch. We appreciate your attention, and I've got kind of detailed references here, including some concurrent work that we heard about just over the weekend at the conference. So Thank you for your attention, and feel free to swing by the poster session.